Hello everyone, welcome to my video. Today we're going to look into a very interesting relation. That is an equation written down by Ramanujan. And the equation states this. You have x plus n is equal to square root of n squared plus x square root of n squared plus x plus n square root of n squared plus x plus 2n square root of, and so on. So this continues indefinitely, and we want to use this relation to solve a question today. But before that, let's get an intuition about this extraordinary relation. So how do we prove this, or how do we get an intuition rather than proving it fully? So we can start with x plus n and say x plus n is equal to x plus n squared, square rooted, okay? And you can rewrite that as that's equal to square root of n squared plus x into x plus n plus n. And you reckon that the two expressions here are the same. So in other words, if we expand and simplify this, what are we going to get? We're going to get n squared plus xn plus xn. Then we have n squared plus 2xn plus x squared. That's the same as n plus x squared. So we haven't changed anything. Okay, so let's do one more step. Well, perhaps two more steps until it's crystal clear. So you can rewrite that expression that I've highlighted in yellow as square root of n squared plus x square root of n plus x plus n all squared, everything inside the second square root. Yeah. So okay, one last time, let's have a look at it. That this is to ensure that we have the same expression, that we haven't changed anything. So you have n squared plus x square root of. So if you, well, what you have inside the bracket is this. In other words, you can get rid of the square root sign and that. So we have n squared plus x into 2n plus x. So you can write it as x plus n, which is the same as the previous form. Yeah. So let's do one more step to understand even better. So we have square root sign n squared plus x square root of. That would be n squared plus x plus n. And then we have x plus n plus 2n, which is the same as that. Yeah. So if you keep doing this, if you keep repeating this step, you're going to get the relation that I've written down here. Okay. Now let's solve a question using this relation. Let me copy and paste this to here. Okay. So the question is, we have square root of 1 plus 2, and then square root of, 1 plus 3, square root of 1 plus 4, square root of 1 plus, and so on, right? So what is this equal to? Okay, well, I'll give you a minute to think and try to solve, and then we'll solve it together. Okay, so, well, the answer will simply be 3, isn't it? Because if you compare the above expression equation with this expression, so we have n squared is 1, so n is 1, x is 2, so x, and you can check that, you know, you have 1 plus x plus n, which is 2 plus 1, which is 3, and so on. Yeah. Okay, so we know that's equal to x plus n, so that's equal to, well, we know x is 2 and is 1, so that is 2 plus 1, which is equal to 3. Okay. Thanks so much for joining. I hope you liked it. I hope you enjoyed it, and I look forward to seeing you in the future videos. Thank you.